Um, so far, we have 3 types of the hypothesis testing. So let me summarize just before today's topic. Yes, just before today's one. We have 3 types. The first one was the z-test, t-test, and the last one was the z-test again. First 2 for a mean, and the last one was for a proportion. So the z-score was given from sigma, the given sigma. So x bar minus mu 0 sigma over square root of n. And the t-test statistic, when we don't know the sigma, x bar minus mu 0 s over square root of n. And the last one is a z again with the proportion p hat minus p0 p0 q0 over n. So so far we have 3 kinds of the hypothesis test, right? In chapter 7, we are going to have 6 kinds of. Remember the 6 kinds of the competency intervals. So today we are going to have the second line, 2 samples. First, we had 1 sample, but from today we are going to have 2 samples. It's good, right? So this one, 2 samples from today. Good, right? Yeah. Any question? So we are going to test for the mean difference. Sigma is known, unknown, right? Yeah. Z or T. And the last one will be the proportion difference. Yeah, that is the remaining topics. So let me go to, yes, here, today's topic. First of all, we are going to discuss the dependent 2 sample. So now we have a 2 sample, sample number 1, sample number 2, but they are dependent. So please look at the example. In this example, it's a paired data. So shoe company claims the average length of the left foot bigger than right. How do you think? Do you believe it? Right? It's very interesting. The left one is the longer than the right one. My shoe size is 8. The left one is 8. My shoe size. What do you expect, right? Why not? Yeah. But foot, not the shoe size. The foot. They claim left one is a little bit bigger. A little bit. What is your shoe size? 13. How about the right one? Same. Yeah. It's almost the same. Yeah. So he has bigger left foot than me. He has bigger right foot. Yeah. Why not? And how about the hands? I have a small left one and a small right one. He has bigger, right? Yeah. We can make a pair. For the 2 sample, left one, right? Then with dependent sample, then always we can make the pair. So this one and this one. This one and this one. This one and this one. Right? Yeah. Husband and wife. A sample is a husband, the other sample is a wife. we can make a pair, right? Yeah. Anybody twins?
I have twins.
You are twins. Yeah, identical twins, right?
Fraternal.
So twins.
Yes.
Another example is individual, the two persons, but yeah, identical twins or any other twins, triples. Yeah, yeah. It is we can make a pair, right? Do you have sisters, brothers? Yeah, sister, your sister or brother?
I have 3 sisters.
3 sisters. Are they taller than me? No?
Most of them are younger.
Oh, really? Okay. I have 3 sisters. What do you expect? Are they 6 feet? No. Yeah, somewhere over here, right? Yeah. In the same family, from the same parents, yeah, related, dependent, right? It's a related, right? Probably the younger sister is grown up later. So in this case, when we have a paired data, dependent sample, always we can take the difference. So now we can take the difference. The left one minus the right one. If the claim is true, if the left foot is longer than right foot, what do you expect the difference? Positive or negative? Positive. When the claim is true, then simply we expect the difference in this way, left one minus right one, must be positive. It's good, right? So when we have a dependent two sample, we can make the difference. And simply we apply t-test. Let me go up to the summary, right? Yeah, here. It's actually the first line, we got one sample, right? But now we have a dependent two samples, right? But we take the difference. That will be one variable. So I want to plug the paired t-test on the border here. Paired t-test. Actually, we got the two samples, but they are different. Dependent. So we take the difference. So simply, we just take the t-test. So we are going to take the mean of the differences, standard deviation of the differences, right? And plug the number of the differences to get the t-test statistic. And we are going to look for the probability from the t-table. Okay? So let me show you another example. Yes, here. In this example, we have 9 patients. Where is the 9 patients? I can see the number of 9. Yeah, here, 9. And they measure the anxiety, right? And they have a new counseling program. What they want? If the program reduced anxiety level. So the first patients, before counseling, the anxiety level 121. After 76.
Wow.
Wow, reduced by 45. Second patient, it doesn't work, right? Yeah. So it's before and after. Before and after, it is another good example for the paired sample, dependent. The third patient, number 3, yeah, reduced from 105. Yeah, sometimes, yeah, why not? Sometimes it increased, but it's only 2 points. But the others, positive, 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 positive. What does it mean? Positive difference. Reduced, right? Yeah. So in this case, we have two groups, before, after, but they are different. So we can make the pair. It's like this. And we take one sample, title, the difference. So now we can state the null hypothesis. Basically, we compare two samples. And now we want to test reduced. How do you think? You know, we have three types of alternative hypotheses: bigger than, less than, or not equal to. In this example, we want to test if the program reduces anxiety. Just a second. What is the one? Before. What is the two? After. Before, when reduced, after must be here. Greater than 0. Greater than. Does it make sense? Yeah, it is a greater than. It's a greater than, right? Yeah. Then we can state the program reduced anxiety. Yeah. The other way, I can make another notation. Mu d, the mean of the differences, is equal to mu1 minus mu2, then must be equal to 0 in the null. But how about the alternative hypothesis? It's greater than 0. Positive. The positive difference means reduced, right? Yeah. So we want to test is greater than 0. Already I posted 2 days of homework. In the 2 days of homework is one question asked you to state the null hypothesis for the paired t-test. You have to state like this way. It's equal to 0. Mu and subscript the d. So in the homework, you have to take the mu for the Greek letter and underbar d is equal to 0 in the homework. Do you know where is underbar? It's on the keyboard, right? As I click the shift and keep it at the minus sign. Yeah, the dash, the minus sign. The shift minus sign, that is the underbar, and plug the d, then that will be the mu d is equal to 0. Yeah, in the homework. And also, I told you the test statistic will be exactly same as the t-test, right? So we need the t-score, d bar minus the initial setting value 0. Always we are going to ignore the second part. And we need the standard deviation over square root of the n. This example doesn't give us the mean and the standard deviation. So let me take the mean and the standard deviation from the Excel. So let me plug the 45, 0, 41, -2, 48, 18, 63, 51, 36. Then now let me take the average. 33.33. Let me take the 2 decimals. Format, number, 2 decimal places. And also using the standard deviation dot s for the sample standard deviation, that will be 22.92. So it is the mean of the d, and this one is a standard deviation of the difference. Yeah, please copy. Yeah, please copy the mean of the differences and the standard deviation of the difference. Then now let me take the mean of the differences, 33.33. Let me ignore the subtract 0, is nothing. And the standard deviation was a 20 what?
22.92.
92 over How many patients? 9. Thank you. Just a second. I have to. Okay, just a second. Okay, good. Okay. So how much will be the t-score? 33.33. Let me take the denominator. It's a 22.92 over square root of 3. It is a 7.64.
Let me square root of 9.
Oh, just a second. That is the 4.363.
Wouldn't it be 22.92 over square root of 9?
That is a 7.64.
We use it over the square root of 3.
I did the square root of 9. So simply just divide by 3. That is the 7.64. And finally, the test statistic t-score is 4.363. Step 2. In step 2. Next step 3, I need the probability. I need the p-value. From what table? T-table, right? Yeah. In the T-table, we needed degree of freedom. How many degree of freedom? 8. I told you it is the same as the previous t-test, right? So the degree of freedom must be 8. So let me open the T-table. Chapter 7, T-table. Yeah, here. T-table. How many degree of freedom? 8. Thank you. 8. Did I state it as a one-tailed or two-tailed? We stated it's a bigger than 0, bigger than, right tail, one tail. And now, how much was the t-score? 4.363. 4.363. Do you remember? How did you get the p-value from t-table? The p-value from 0.0005 up to 0.005. So let me go back to the note. Now then p-value, step 3, 0.0005 less than 0.005. Alpha, we didn't have the alpha. Let me give you the alpha. To make the conclusion at alpha 5%, 0.05. Is the p-value less than alpha or bigger than alpha? Much less than alpha, 5%. Then what will be the conclusion? Reject. Did you say do not accept?
Yeah.
No, please don't say accept. Reject, HO. Reject, HO, because p-value less than alpha. Reject, HO. Step 5, we have to interpret H1, alternative hypothesis. What does it mean? mu1 is bigger than mu2. Before higher than after. What does it mean?
The counseling program works.
It worked. It worked, right? The counseling program reduced the anxiety level, right? Yeah, simply I just say the new counseling program reduced the anxiety level. It worked. Yeah, see? Exactly same It's a t-test. But what's the difference? At the beginning, we got 270, but they are dependent. Take the difference, apply, simply just apply the t-test. Here's another example. It is an example from the education regarding the education, toys, and reading age. You know, when you visit the Walmart, the section of the children, there are so many kinds of educational toys, right? So they recruit 6 pairs of twins, okay? And they did the experiment. One twin was given educational toy and they did, right? And they measured the reading age. Randomly assigned, one is here and the other one is there, right? Assign the toys and not, right? Randomly. So the mean difference of the age, reading age, is negative 2.33. And yeah, it's directly, this example gives us the test statistic. It's a negative 2.642 from the mean difference, right? So in this example, I want to test the mu d is equal to 0 always, but they just want to check the difference. And the second step, the test statistic was given negative 2.642. Then now I need the p-value. The range of the p-value from the t-table. Give me the degree of freedom. They sample 6 twins. How many degree of freedom? No, 5. Everything is based on the differences. When I take the 6 and 6, 12 children, but when we take the differences, we are going to get 6 differences. Minus 1 will be 5.
Pairs.
6 pairs. Yeah, the degree of freedom must be 5. 2 tail, right? So I have to go to 5, 2 tails. How much was the test statistic? The test statistic was negative 2.64. Always we ignore the negative sign because the t-table has only the positive values, 2.6 something here. And going up, p-value from the 2 tail between 2% and 5%. So I can suggest the p-value from 0.02 less than 0.05. How much was the alpha?
0.
Thank you. So p-value is less than alpha, 0.05. Less than.
One of them is 0.05. Less than or equal to.
What do you mean?
The alpha is 0.05,
Uh-huh.
and the variable is 0.03, the p-value is 0.05.
Yes, 0.05.
If it was 0.05, then the t-score would be right above where that comes down. At the top of the t-score.
Yeah, please look at that. There is a 0.05, 0.02. Between 2%, 5%. Less than 5%. Less than 5%. So we reject the null hypothesis. Now the conclusion, there's a number 3 and 4, reject the null hypothesis. Reject. There's a difference. What's the difference? Reading age. Because why? Because of the educational tool. When you will get married and have some children, buy the educational tool. It's good for them, right? Yeah. They are different. So now it is the paired t-test. So I suggested in the middle, yeah, on the border, right? Because it's actually, we had 2 samples, but they are different. Dependent. They are dependent. So we made difference, right? So simply we apply the t-test, right? So I just put in the board, right? And the next topic is this. The next topic is this. Do you remember what was that in chapter 7? We assumed we knew the 2 sigmas. And we use the Z, right? Yeah. So that will be the second topic today. And what will be the next? S1, S2, T, right? Yeah. And the last topic will be the proportion difference. P1 hat, P2 hat. Using the Z is later. So let me show you as my schedule. Today, Wednesday, we are going to use that one, the blue one. 2 sigmas and Z test. Friday, we are going to discuss the next one. 2 S's and T test. Next Monday, May 1st, we are going to discuss the last topic, the proportion difference. Wednesday, May 3rd, I'm going to review from chapter 1 to 5. Second review on Friday from chapter 6, 7, and 8. You know, the chapter 6 title was the normal distribution. Confidence interval, hypothesis tests is based on the normal distribution. So on this Friday, it's May 5th, I'm going to review chapter 6, 7, and 8. Everything is based on the normal distribution. And the first review Wednesday from chapter 1 to 5, right? Yeah. And then we are going to take the final exam Friday. When do we have an exam? Monday. Oh, it will be the Monday. The Monday, May 8th at noon. It's Monday 8th at noon, right? Yeah. And absolutely next week, in this weekend, I will open again all homeworks after the exam number 3. And also I will post the review homeworks again from chapter 1 to 8, right? So already you got the good scores, right? Then you don't have to make them up. Yeah, simply just try the review homeworks when you are preparing the final. And remember how many summaries? How many pages for your summary? As many. Yeah, I told you. Yeah, I told you. So you can bring your note. Yeah, good. You can bring your note because it must be handwritten. And also, why not? You have to bring the Z table and T table, right? And also, you can print out my summary. So let me show you. When you go to the Blackboard, lecture notes, see, right? There is a summary from chapter 1 to 4, 4 to 6, 6 to 7, and 8. You know, already I emailed you, right? But if you want the new clean one, right? Yeah, just print out, download and print out, and you can bring it, right? And tables, and you can prepare your summary. But remember, handwriting, as many pages you want. Okay, yeah, it's in the final exam. In the final exam, Monday at noon. So that is my plan. That is my schedule, right? So let me take the Z test, right? Yeah. So let me go down. Yeah, it is the paired T test. And now here we are going to discuss the testing for the mean difference. And Friday we are going to discuss the proportion difference. Friday. No, next Monday, I'm sorry. Yeah. And now we have a independent two samples. It's like as a male or female who are taking statistics or not. So they are independent. And we assume we knew the sigmas, yeah? So we are going to apply the z-test. Yeah, it is the test statistic, but let me remind you what was the confidence interval. In chapter 7, already we got the confidence interval for the mean difference, which was the sample mean difference plus and minus the z with the sigmas times sigma 1 square over n1 plus sigma 2 square over n2. Do you remember the confidence interval for the mean difference? Look at this. Here is a square root, square root, square root. Same. And now here, x1 bar minus x2 bar. Here's the sample mean difference. And we got the z-score and the z-score. Yeah, exactly same idea. Exactly same idea. We just rearrange to get the fraction, to get the test statistic from the confidence interval. Absolutely, the confidence interval was from the sampling distribution, right? Yeah. It's almost the same thing. And now, please comparing the middle one and the right-hand side. What's the difference? Yeah, here is the mean difference. I'm sorry, it's the green one. I have the highlight with the green color. What's the difference? Oh my God. What's the difference? It is not there. Do you know why? Because we want to state the null hypothesis. Mu1 is equal to mu2. Simply, we just compare independent two samples. And it means the difference will be 0. The difference will be 0 always. So always we ignore the mu1 minus mu2. That is 0 in the null hypothesis. So we are going to use the right-hand formula, the right-hand the fraction of the test statistic. And it will be the z because we assume we knew the signal. Friday, we are going to get the t-score with the S1, S2 is later. Okay, so let me look at the next example. Yep. We assumed we knew we have the two sigmas, right? And now here we have two models for testing camp stove and to test the heating capacity, right? And they measure the time required. Is boiling 2 quarters of water from 50 Fahrenheit to the boiling point, right? Model number 1, it took 11.4 minutes on average. Second one, 9.9 minutes. Which one is better? Which one is the powerful? Is more powerful? 9.9. Shorter, faster, better. It's more powerful. Does it make sense, right? So now we have independent two models, and now I want to test different two-tail. So let me state the null hypothesis always is mu1 is equal to mu2, but alternative hypothesis is not equal to, so it will be two-tail. Remember, we are going to apply the z-test, and we are going to take the probability from the z-table, and don't forget twice, because it is a two-tail. Okay, then now the test statistic, the z will be x1 bar minus x2 bar square root of sigma 1 square over n1 plus sigma 2 square over N2. Then let me plug the statistics. Let me see, it's 11.4 minus 9.9, then 2.5 square over 10, and 3.0 square over 12. Now we have an independent two sample. The sample size, they don't have to be same. But before the dependent sample, we have to make the pair. The paired data, they must have the same sample size. Do you understand what I'm saying? Right? But now we have an independent two sample, so they don't have to get the same sample size. So let me take the mean difference, 11.4 minus 9.9. It will be 1.5. And the denominator, take the square root of 2.5 square over 10 and 3 square over 12. Then it will be 1.1726. Then the test statistic, the fraction will be 1.5 over 1.1726 will be 1.279. You know, it is a z-score. Always we needed 2 decimal places. So the test statistic will be 1.28. Then now we need the probability from the z-table, from the standard normal distribution z, 1.28. Can you give me the probability from 1.2 and 8? 0.8897 to the left. Where do we need the probability? 2 tails. Let me take the right tail. First, 1 minus 0.8897 will be 0.1103. Just a second. Is it 0.8897 is?
0.8997.
Just a second. Did you say 0.8997? I'm sorry. Yep, it's a 997. Then it must be 1003. It is the probability in the only the right tail, but we stated it's not equal to. It's a take twice. So finally, the p-value will be 0.2006 will be the p-value. Alpha, 5%. Alpha was given 5%. Is it bigger than 5% or less than 5%? Bigger. What will be the conclusion? Bigger than alpha. Not to reject HO. I have to make the conclusion not to reject HO because p-value is bigger than alpha, which was a 0.05. Not to reject HO. Then now I have to interpret the null statement. What is said? They are saying. What are saying? The heating power. The heating power between model number 1 and model number 2. Even model number 1 took 11.4 minutes on average, 9.9 minutes, but statistically, same. Just by the cheaper. It's the same thing. Yeah. The interpretation will be the power is the same. The boiling water, same thing. Okay, so it is the z-test, right? So next Friday, we are going to discuss t-test. Yeah, it's comparing two means again using the t-score, the t-test. And now here is the quiz number 24. Here is the quiz number 24. we want to test for the difference. So the hypothesis must be the null mu1 is equal to mu2. Alternative 1 is not equal to. And the test statistic will be the z. Take the sample mean difference. And then we assumed we knew the sigmas. Sigma 1 square over n1. Sigma 2 square over n2. Okay. 13 minus 15. Then it must be -2. Then 3 square over 49 and what? 4 square over 64. Point 65, 85. Then will be -3.04. Anybody who take the -3.04? -3.04? Negative? Yeah, thank you. Yeah. And p-value -3.04. Left tail. Then twice will be the p-value. Two tail. And additionally make the conclusion. And also you have to make the interpretation. Step 5.
You can also subtract it from one, like.
No. See, how much is the probability from the Z table at negative 3.04? 0.0012. Did you get the probability 0.0012?
Yeah.
It is left tail. We need a probability 2 tails, right? So when we get the left tail, simply just take twice. But please compare to before. Let me go back to the last example. See, look at this. It's a two-tailed again. You know, before it was the two-tail. Same thing. But why we did 1 minus? Because in this case, we got the positive z-score. We found the probability to the left. But we needed right tail. So please remember, it is 2 tails. So we can take the either tails then twice. You understand what I'm saying? So in the quiz, we don't have to do 1 minus.
So if that would have been a positive 3.04, we would have subtracted that one.
Yes. Yeah, because we need the right tail probability. So here's the 0.0012. Twice will be 0.0024. Alpha was given 1%. Yeah, you can make the conclusion.